graph, and we have f of x up here and g of x down here, and we're given the equations for f of x and g of x. On this one, I can kind of tell where they're intersecting, at 0 and at 1. Those are good to know. And so we're first asked to find the area of the shaded region. Easy peasy. So that's going to be f of x minus g of x. Upper function minus the lower function. What's going to happen when I subtract the area of g of x? Well, the area of g of x would have been negative, but when I subtract it, it's going to become positive. So I'm going to get all of this area, and it's going to be nice and pretty. So the first thing I would do is go to my y equals and put in the two equations, because it does say we can use the calculator on this. So we have 2x times 1 minus x and 3x minus 1 times the square root of x. All right, and I'll look at the graph. Oh, why is my graph so crazy? Well, my window is really, really big. So I'm going to hit zoom, and I'm going to go to zoom decimal. And I can see where that hump is from 0 to 1, and I can tell where they're intersecting there. If I wanted to verify that they are definitely intersecting at 1, I could go and do the intersection and verify that they are intersecting at 1, 0. So to find the area of the shaded region, we're going to take the integral from 0 to 1 of f of x minus g of x with respect to x. So in other words, we're making all these little rectangles and adding them up. So alpha window integral from 0 to 1 y1 minus y2 dx. Now remember, when your calculator is doing this, it's actually adding up all those rectangles. So it takes it a few minutes. 1.133. Now it says to find the volume of the solid generated when the shaded region is revolved about the horizontal line y equals 2. Well, that would be way up here, right? So if I'm revolving that around the line y equals 2, I'm going to have this shape with this big opening in the middle. So I need to think about what's going to be my outer radius and then the inner radius. Outer radius would be going from 2 all the way to g of x, and the inner radius, so this is big R, inner radius would be going from here to here. So, and it actually doesn't matter which order you do it in. I like to use the picture to decide. So the volume of that figure is pi 0 to 1, and then it's going to be big R squared, which was 2 minus g of x squared, minus the area with the inner radius, 2 minus f of x squared dx. So we got all these parentheses in here. We've got to be very careful putting it in the calculator. So don't want to put pi in. Remember, I'm going to say pi for dessert. Now that is unless you're in the multiple choice section and they have them all in all decimal, then you would just go ahead and put pi in. But g of x was f2 parentheses squared minus 2 minus f1, which was, f of x, which is y1 squared with respect to x. and it gives me 5.15 pi. Now if I needed to multiply that times pi, that's pretty easy. That's also 16.179, depending on how the answer's set up. Now let h of x be the function given by this. Now that looks very similar to f of x. In f of x, it was 2x parentheses 1 minus x. Very similar. So for each k greater than 0, so because if we had a negative k there, it would reflect it, but we don't want that. So for each k greater than 0, the region enclosed by the graph h and g. So in other words, we could have a taller one, we could have a shorter one, but any h, which is going to be similar to f of x, h and g is the base of a solid with a square cross-section perpendicular to the x-axis. Whoops, sorry. There is a value of k for which the volume of this solid is equal to 15. So let's think about if we had squares going all the way. So we have this curve and then this big curve down here. This is g of x. This would be some h of x. And we're putting all these squares on them perpendicular to the x-axis. I had it right. So these squares would be coming out of my paper. Oh, these are beautiful squares, right? So if I took one of those squares, its width is going to be h of x minus g of x. Both ways. So if I added them all up, now on this one, since it says we're trying to solve for k, I wouldn't just put h of x and g of x. I'd actually use the functions. So it's the integral from 0 to 1 of, it's going to be h minus g squared. So h is kx times 1 minus x minus g, which was 3x minus 1 square root of x. And all of that is being squared because we have a square, h minus g dx. Now it says to us that there's a value x for which the volume is equal to 15. This would be the equation we need to find k. It says don't solve, just set it up. Next problem. Ooh, this one's interesting. We've got two regions in it. We got f of x and g of x. And f of x is given by this function, and g of x is given by this other one. So, first thing I would do is change my y1 to be 1/4 plus sine of pi x. And the other one is going to be 4 to the negative x. Let's see if we get anything similar. Okay, so that's the one with the sine. And then the other one's coming through just so. Love it, I can see it. Now it says that we want to find the area of R. I might change my window here so that I can zoom in a little bit more. Like go from, let's see, that would be about negative 0.1 to, I think, well, let's try 1, and then this would be negative 0.1 to, let's say, 2. See if that shows it. There's that one. Oh, do I have enough? I don't. And there's that one. I need to make my x's a little bit bigger. So this is how you can set your window to help you with the problems. I played with the window. I could have zoomed in as well, but this makes it more useful. Okay, so if we're going to need to find the area of R in one part and then the area of S in another part, I need to know these two intersections, here and here. So I'm going to go in and find where those two graphs intersect. Enter, enter. Now for the first one, I'm going to go over here and find that value. So that is intersecting at, and I might write it up here, 0.1782185, comma, 0.781091174. Okay, so I'm going to let A be that. So I'm going to let A equal 0.1782185. So immediately my calculator want to save that value. So I'm going to go back to the home screen, double check. Right now that should be what X is. Now if I move anything on the graph, that's going to change. But I'm going to store that in A. So from now on, that's A. Cool. To get the area of R, we're going from 0 to A. And let's decide, sometimes I'll use like A sub R. So 0 to A of which one's on top? Well, it's this line right here, which they tell me is g of x minus f of x. So in the calculator, I would go integral 0 to A of g of x I saved in y2 minus y1. .064753. Now if you wanted to write out the whole thing, you could. There's nothing against that, but 3 decimal places is all they really care about. So 0.065. Now find the area of S. Well, I know S starts there and goes to there, so I need to find the other intersection. So second calc, intersect, enter, enter, but this time I want this other intersection point. And so that one is, oh, how nice. That one's at the point 1.25. Beautiful. So I don't really need to save 1 into my calculator. That's easy. So the area of S is going to be A to 1. So from here to here. F of x is on top, g of x is on bottom. So back to the home screen. Integral from A to 1 of y1 minus y2 dx. And I get 0.410. Find the volume of the solid generated when S, the big one, is revolved around the horizontal line y equals -1. So that's going to be way down here. So my outer radius is going to go from f of x to -1, and the inner is g of x to -1. So I know to get the volume of that revolved figure, I'm going to have the integral, oops, I forgot pi, from A to 1, because that's the region of S, of outer radius is going to be f of x minus -1 squared minus the inner radius, g of x, minus -1 squared dx. So we can just plug that into the calculator. being very, very careful with all of our parentheses. And notice I didn't put pi in yet. Save your pi for dessert. Parentheses. That's f1 plus 1 squared minus, that's f2, and y2, sorry, plus 1 squared dx. Now that's giving me my main course. It's 1.451 pi. And that's a totally acceptable answer. I can still, if it's a multiple choice, maybe multiply that times pi and get 4.559. Find the volume of the solid formed by right triangular cross sections perpendicular to the x-axis with the hypotenuse in that base. And so we're still using base S, sorry about that. So in that same base. So right triangular cross sections. Now it didn't tell me which part of that triangle was in the base. Oh, it does. It says the hypotenuse. Oh, great. Okay, so the hypotenuse would be going from perpendicular x-axis, so from F to G. And this is a right triangle. So how would we find the sides? Well, I know if I knew this side, it would be this times the square root of 2. So to go backwards, it'd be divided by the square root of 2. So to find the area of that triangle, it'd be 1/2 that side times that side. So 1/2 of f minus g over square root of 2 squared. Well, when I square that, it's just going to give me a 2, so that's 1/4 f minus g squared. So my volume would be 1/4 a to 1 of f of x minus g of x squared dx. And I'm not going to show you putting it in the calculator because I think you know how to do that. I got 0.0626. Ooh, I like this one. Set up but do not evaluate a definite integral to find the volume of the solid generated by region R about the y-axis. So region R would be this way and this way. Oh, that's interesting. I have to solve for x. That's going to be neat. Okay, so about the y-axis. Ooh. All right, so f of x, so the first one is y equals 1/4 plus sine of pi x. If I'm solving for x, how do we undo sine? Well, that's the inverse of sine. And then we would just divide by pi. So that's one of ours. The other one and maybe I'll use a different color for this one, was y equals 4 to the negative x. Well, the easy way to do this is to take the natural log of both sides, because that's going to come down into the front. Negative x, natural log of 4, divide by natural log of 4, and then divide by negative 1. The good thing about this is we don't actually have to solve it. It says just set it up. Okay, so, ooh, hold on a minute. Let's look at it now. So, if we're revolving this about the y-axis, ooh, I didn't make up this problem, sorry guys. It's going to have a mirror image like this, and it's revolving this way. So I'm going to be cutting into this. So I end up with two different little, like this would be a little cone up here, and this is going to be a cone down here. So we have two separate pieces. I also need to find where it starts and stops. My goodness. Okay, so how do we find those? Well, let's look at the graph. Those are when each function is at 0. So I'm going to trace and hit 0. That's going to take me to my y-intercept, and it says right here the y value is 0.25. So I need to go to the other one and hit trace 0. Oops, I didn't go to the other graph. Why am I not getting that? Oh, let's look at the table. When x is 0, oh, it's at 1. All right. So, from 0.25 to that value, we have f of x. This is a complicated one. I haven't seen one that looks just like this before. So it'd be pi, let's see that again, 0.25 to the y value of the intersection of, this was the first one, inverse sine of y minus 1/4 over pi, all of that squared dy. Oops, sorry, you couldn't even see that. Plus pi of 0.781097174 to 1 of natural log of y over natural log of 4 squared dy. I don't know if I've seen that one that complicated, but this would be testing some of your pre-cal knowledge. And then dividing it up is, that's the calculus part. So the hard part is the algebra here. Let's keep going. Let's see what's next. Let R be the region in the first and second quadrants bounded by the graph of y equals 20. I'm sorry, you can hear my doggy today. Let's see. So let's do it in a fraction because that makes it easier. 20 over 1 plus x squared. And let's look at the graph. Oh, I forgot I was zoomed in. Let me go zoom. Let's go decimal. Let's see what that does. below the horizontal line y equals 2. So let me put that one in there. Oh, so we're talking about this area. The graph of 20 plus, okay, so this curve and that line. See what we get. So the area would be zoom out a little bit. Is it ever going to actually equal 0? Let me pause on this one. Let me get back to you guys. We're going to skip that one and go on to this last one. I think there was a typo on the previous one on page 3. So let R be the region bounded by the graph y equals, clear out what I had, e to the 2x minus x squared, and the horizontal line y equals 2. I might need to go back to my other window. I had zoomed out on the last problem, so zoom decimal tends to be a pretty good one sometimes. Oh, there it is. So that's R right there. And then S, oh, it's that one right there. So I need to find these intersections. So I'm going to do second trace, intersect, inner, inner, and then inner. Okay, so the first one's at 0.44605703. I immediately am going to go to my home screen and store that in A. Now I'm going to go find the other intersection. This time I have to scoot over, and that's at 1.553943. So the area of R would be the integral from A to B, so area sub R, of what's on top? Well, that's the y e to the 2x minus x squared minus the horizontal line of 2. Easy peasy. Let's set up the next one. Area of S. So that one's going along y equals 1. Now when I go in to find the intersection now, it's going to ask me, do you want to use y1 as your first curve? I'm going to press enter. But do I want to use y equals 2? No, I want to go down to y equals 1. And we're double checking that they are intersecting at 0 there. That's good. Now I want to find the other intersection. Inner, inner, scroll over, inner. Oops, I think I hit something wrong. There we go. Intersections at 2, 1. Oh, that's nice. That one's intersecting at some nice places. So the area of S would be 0 to 2 of e to the 2x minus x squared. Oh, wait, it's... Oh, this one's interesting. Oh, I went too fast. It's not the whole way through, is it? second guess myself here. What ends up happening on this graph? Let's look at it. If I just found the area between e to the 2x minus x squared and 1, I'd be finding this entire region. But I only want s. Oh, so why don't I find the area of the entire thing and then subtract out the area of r? So that would be from 0 to 2 of e to the 2x minus x squared minus 1, and then subtract the area of r. Let me show you how to do that on the calculator. So let's go ahead and find the area of r. I kind of skipped that part because I knew I was going to need to go through this. So from A to, oh, we forgot to save B, didn't we? Oh, that's okay. I'll just type it in real quick. 1.553943 of y1 minus 2 dx. 0.514. Now, to find s, I'm going to do the integral from 0 to 2 of y1 minus 1 dx. But I want to subtract out the area we just found. So here's a nice little trick. Minus the last thing we just found. 1.546. Write but do not evaluate an integral expression that gives the volume of the solid rotated around r rotated around y equals 1. So we're going to have a hole in there. We're going to have a washer. So I need to do the outer radius minus the inner radius. So, okay, let's do it. That's going to be from A to B. Oops, pi. The outer radius is going to be e to the 2x minus x squared minus 1, because we're rotating around the line 1, minus the inner is going to be 2 minus 1 squared. And we're getting serenaded by my dog being an idiot. Hi, Meg. I'm recording this video in our back room, and she's just going nuts outside. I got 1.3199 pi. Saving my pie for dessert. 4.147.